Good morning, everybody, and welcome to this webinar on our use-based consolidated results program. And I'd like to welcome you on behalf of the SESAR joint undertaking under the auspices of the SESAR Digital Academy. It'll be our pleasure today to talk to you about the results from the use-based program we've been running now for more than 2 years. We have some great speakers today for you who have been involved with the collation of the results. But first, I'd like to talk to you about some admin. We're running using the Livestorm platform, and you'll see on the right-hand side of your screen some tabs. The one that's really important to you today is the one called Questions. As the presenters go through their material, you're free to add questions here, but you will not be able to actually speak at all. We can collate the questions, we can respond to the questions on the fly and verbally towards the end in the final half an hour, which is dedicated to a discussion. Please do not use the tab that's marked chat, because if you start sending us messages on chat, it'll be purely a matter of good fortune whether we pick it up or not. If you wish to say something to us for use, then please use the questions. So, with no further ado, I'd like to move on to the start of our presentations, and I'm very, very pleased to welcome the Executive Director of the SESAR Joint Undertaking, Mr. Florian Guillemets.
Thank you, Robin, and good morning to all. I just want to do a very brief introduction to the session you will have today with Robin and the rest of the team who's been actively working on the use-based domain. Just to recall that what we're going to present to you today is the outcome of 3 years of very intense work. It all started back in 2017 with a mandate we received from the European Commission to boost the use space, in particular in the domain of U1, U2 through demonstrators. But as you know, we've worked as well on the other levels of services. It started with the blueprint that somehow is still the type of roadmap that we are following today in terms of development of the use space. And I think the value of it was really to aggregate the community on a first type of common vision that was then further developed through concept of operations and, of course, the work that has been performed by the different projects. There's a lot of noise usually around drone and use space, and of course, there are always high-level conferences and a lot of expectations about it. I think today is really the time when we are trying to take stock of what has been achieved during this 3-year period, where we had a significant number of projects working on the concrete services of the use space, of the enabling of drone operation in the European airspace. We worked in total with more than 125 companies, and it's been really a collective effort. And from the feedback we got from these companies, this has been something which kind of instrumental in helping them to further evolve the services, to know what is working in concrete terms, but as well to know what remains to be done. And this is probably where we will have to focus. I think what we have today in our hands with the use-based report that we are tabling is the state of the art regarding the solutions that have been envisaged in the context of the development of use-space. Some of them, they do work, some of them they work, but they don't necessarily deliver the level of performance that is required. And for some others, we do need to perform further investment in terms of R&D and innovation to bring concrete solutions on board, because we still miss them. And I think this is really what the report is going to table, and this is what you will be presented with today in this very session. I just wanted to conclude that this is indeed a collective effort. It's an effort that we have undertaken with a lot of support and a lot of coordination, in particular with EASA, but as well with the Eurocontrol team that you have here today with us, and that will show what has been done from their standpoint. But I really want to thank them, because what we have been able to do over the last 3 years would not have been possible without this very strong support. That's really it from my side. I wish you an interesting session and as well a useful session, and I'm sure you learn a lot through this webinar. Thanks a lot, and again, have a good session. I hand over to you, Robin.
Thank you, Florian. Thank you very much indeed. Well, good morning again, everybody. Just a brief introduction now. What I will be doing now is to, let me just get my screen up and working. Okay. Yes. Now what I shall do is give a brief introduction to the SESAR JU Space Research Program. For those who do not know me, my name is Robin Garrity. I am an air traffic management expert with the SESAR joint undertaking, former air traffic controller, and I've been responsible for overseeing the content, technical and operational content of the JU Space program. So, as Florian indicated in his introduction, this started back in 2017 with the Helsinki Declaration, where it was clear that we needed to do some work to try and put some order into the rapidly increasing drone market. And the term U-Space was coined to represent UAS traffic management in Europe. And SESAR Joint Undertaking was given the task to create and run a research program. This was no mean feat. If you can see, in 2017, we started almost from nothing. Previously, we had produced the European Drone Outlook study, which kind of quantified the market. And we had a few lines in the then version of the European Air Traffic Master Plan, although it was mostly a line here, a line there, and some footnotes, not anything particularly substantial. We wrote the blueprint that Florian referred to, which really set the vision for how we saw things evolving, and at the same time created 9 exploratory research projects, one of which was dedicated, chorus, to the definition of a concept of operations for drone operations within Europe. This then proceeded, and we created another document looking at the principles on the architecture of U-Space, and at about the same time started 10 demonstration projects. Now, it seems strange, if you understand anything about SESAR, or about what exploratory research is and what the demonstrations are, to have them running at the same time. But in fact, such was the pace of the drone market, we needed to get things in the air and get stakeholders talking to each other, working together, trying things out operationally, technologically, speaking to regulators, speaking to navigation service providers, just to see what could be done. And the demonstrations worked alongside the exploratory research projects to try and make sure the results were harmonized. The chorus concept of operations matured through 3 iterations until it was finally delivered in its current version. At the same time, we were executing the flight trials as part of the demonstrations, and we started to get the results from the exploratory research program. So by the end of 2019, most of the projects were winding down, and we had an enormous amount of material from the various projects that led to the publication of where we are today, which is with the consolidated results report, which has now been made publicly available. Now, when I say it was a large task and a massive amount of information, take a look at some of this. We had 125 entities involved from 19 countries with 850 hours, with over 186 flights. This represents a magnificent effort from all over Europe. 25 European airports, 25 air navigation service providers, and more than 800 experts across Europe. And the final figure there is these 19 projects. That's the 9 exploratory research and 10 demonstration projects. Now, when you hear the numbers, they all kind of blur. This gives you a better impression of exactly what we're talking about. That's each of the project's logos. Each of those projects had large multinational teams working on various elements of the drone integration problem, and there was overlap, but it was carefully constructed overlap, and the whole was run as a coordinated program from virtually every state in Europe. And these results are what we have collated today into the results that we're going to be presenting to you. There are a couple of things you need to be aware of because you'll be referring back to it. So in case you're not aware of them, one thing that the USpace blueprint gave us was the concept of the maturity levels or the complexity levels, if you like, of the services available within the USpace environment. And these were named U1, U2, U3, and U4. With U1 being the foundation, U3 being advanced, U4 being full services. Now, you have to understand this is not like a waterfall model where you move from U1 to U2. They build on each other, which this graphic shows quite clearly. So the foundation services such as registration and identification and geofencing will be there throughout, and then you get to the more advanced systems in U2. So we'll see more about what the services are later on, until finally in U4 we'll have everything, but it still uses the U1 services as well. And one thing this presentation set will show you is the maturity we are with each of these different states. So another thing you'll see again, and you'll see this slide again, is the concept of USpace is a service-based environment. It is actually a group of services that build collectively into a suite of services that will enable USpace operation, and that requires, of course, technological and procedural interfaces between all the various services to be managed by multiple service providers. And that is something else we'll hear more about later on in the presentation, so I won't go into detail about exactly what's on this slide just yet. But of course, it's all very well coming up with a nice idea about how services work together, but this also has to be supported by a regulatory environment and by standards that enable the connectivity. So you can see in some numbers here that the number of recommendations that are made into standardization regulation, which are fairly considerable. And so we are trying to make direct support to the regulatory bodies from the Commission and the EASA, and also feed the standardization bodies such as EUROCAE to help bring this together in a pan-European fashion. So what we have later for you for the presentations now, I'll shortly hand over to Andrew Haitley. As Florian said in his introduction, this would not have been possible without a tremendous cooperation and close working between the SESAR Joint Undertaking and Eurocontrol. So I'm pleased here to be able to demonstrate this cooperation in action with the principal authors of the various parts of the report that we've released today. And as first of all, starting with Andrew Haitley from Eurocontrol, who will start to discuss U2, the maturity of U2. Then we'll move on to Giancarlo Ferrara, who'll talk about how we've even taken steps towards U3 maturity, where we are, what works, and how mature we are. And then last but not least, we'll be showing presentations by Ludovic Legros, who is actually a Eurocontrol employee. He's seconded to the SESAR Joint Undertaking, and he has been throughout the process the manager and head of the SESAR USpace program. So with no further ado, I'd like to introduce Andrew Haitley, who, after working at Western Helicopters and then a small technology startup, Andrew joined Eurocontrol's Network Management Directorate, then the CFMU, where he helped develop the IFBS system. After working at Budapest to work as a simulation engineer, he transferred to the Eurocontrol Experimental Center in 2010. Andrew was technological coordinator of the Chorus project and has subsequently participated in a number of drone research projects, as well as acting as a lead contributor to the results consolidation of the SESAR USpace program. Over to you, Andrew.
Okay, you see my presentation okay?
Yes, we see it.
Okay, at the end, if I can't get control of the webinar back, can you just grab it, Robin?
I will, of course.
Okay, here we go. So the brochure, which is available for download today, talks about all of the different services in USpace. These services are described in the blueprint document, and then the Chorus ConOps describes them in some detail. But today, for lack of time, I'm going to quickly focus on just a small number of U2 services. The ones concerning geo-awareness, so the provision of geofence information, notification of changes. The ones concerning strategic conflict resolution, and the services related to tracking, conformance monitoring, and traffic information. So I just want to talk briefly about what we've done in these 10 demonstration projects, and sometimes in the 9 research projects. And so there are 3 little case studies on these U2 services to describe how we have a feeling for the level of maturity. And I'll start here with the project GeoSafe, whose main focus was geo-awareness, and have a little extract from the GeoSafe the GeoSafe project. And here we see that they were making some real tests using current geofencing implementation, looking at the current sources of geofence data, which was the conventional aeronautical information, and also the performance of current implementations of geofencing. And here they measured a drone as it flew around an existing geofence, and they saw that it kept a 17-meter or 50 feet boundary from the geofence. The Diode project was again looking at many different aspects of U-space, but they drew their geofence data both from the aeronautical information and from other sources. They had drone-specific aeronautical information, and they were testing both the checking of geofences during operation planning and also the creation of drone aeronautical information and its dissemination during flight. So geofences were being created tactically, and pilots and so on were being notified. And they were able to do this, and they concluded this tactical geofencing was an extremely valuable activity in terms of increasing the safety of the system. The DOMAS project was explicitly focusing on simultaneous U-space providers in the same area. And they were looking at the performance of these simultaneous U-space providers, and they were looking for things like consistent behavior, for the timely spreading of information. Would checking of a geofence produce the same result using different U-space service providers? And this picture, which comes from the DOMAS report, shows this pink rectangle, which is a tactically created geofence, which has been sent between the U-space service providers and is impacting 3 different drones here, shown as these little symbols on the map. And they concluded that this ability to create emergency geofences was extremely valuable, and they demonstrated that it is possible to implement this now with the current technology. So overall, the different projects produce a very large number of different requirements for how to implement geo-awareness. These requirements come from both the exploratory projects and the demonstration projects. And the bulk of them focus on the technical requirements for interoperability and technical implementation details. But they addressed all the 5 different aware areas of requirements, including public acceptability, secure implementation, maintenance of safety, and so on. The second service I'm interested to talk about today is the strategic conflict resolution. And one of the demonstration projects, Eurodrone, was focused on vehicle-to-vehicle communication. But as part of the project, they developed a strategic conflict resolution tool, which they called Partake. And they did quite a lot of measurement of this tool, both in simulation and real flight operations. And they were beginning to produce operational requirements based on their experience, on first-hand examination, and they produced this proposed figure of 150 meters for the separation during these early stages of U-Space implementation. The Safe Drone project was looking at the interaction of UAS and manned aircraft in the very low-level airspace. And strategic deconfliction for them was very important because of the large numbers of drones that they were operating in confined spaces. This picture shows an overview, an aerial photograph of a disused airfield, or maybe not disused, but an airfield where they were flying 7 drones simultaneously, and then a manned aircraft entered the scene a few minutes later. But in order to operate these 7 drones simultaneously, they deconflicted the flights before takeoff. So they had an effective implementation of strategic deconfliction, and they felt the benefit of it very clearly in their work. The Sapphire project is particularly noteworthy in terms of strategic conflict resolution because they focused on multiple use-space service providers in the same environment, and they implemented a discovery service, which is a service that allows use-space providers to discover when 2 of them have an overlapping interest in a 4D volume. They got this working according to the emerging standard being developed by ASTM, and they implemented it. And here you see a picture of Antwerp Airport. The red box is an area of interest expressed by one use-based service provider, and the green wedges, which you can perhaps make out, are the path of a flight which is in the other system. And they were able to rapidly identify strategic conflicts and even rapidly enough to consider using this for tactical conflict resolution. So again, large number of requirements coming from the work on strategic conflict resolution. A great deal said about the implementation, about how to standardize this, about how to go on to deploy it. So most of these relating to interoperability and technical requirements, and minimum performance. But still some in the other areas about how to implement this acceptably and so on. The tracking use case was of great interest, and Podium, the project which took place on 4 different sites in 3 different countries, spent a great deal of effort to get tracking working. And they said at length in their report how important tracking is. Situational awareness, sharing situational awareness with air traffic control, sharing situational awareness with the drone operators is essential for maintaining safety. And here you see a picture taken from the exercise. I think this is the one in France. Oh no, this is Odense. Yeah, so that they produced quite a long statement about the importance of tracking and its value in terms of safety. The USIS project, which occurred in Hungary and in France, was using conventional tracking, that is ADS-B and Mode-S. And because of this, their tracks were visible to air traffic control, but in their experimental setup, the drone pilots had no situational awareness. And the drone pilots complained bitterly about this. So this is another statement that situational awareness is something which is needed, and tracking is an important element of the U2 implementation, which brings a great deal of safety. The Vutura project was explicitly having 2 use-space operators in the same volume of airspace operating simultaneously, some flights connected to one, some flights connected to the other, and the data shared at the use-space service provider level. They used a number of different technologies for tracking, including LoRa, which is promising because it's cheap and long range. and adequate for the job, as they showed. And here you see two pictures from two different use-based service providers' systems. These pictures were taken at slightly different times, which is why the dots don't quite line up. But they clearly show that they are able to exchange track information and create the same situational awareness. And the project, again, focused on the exchange, dissemination of track information between the use-based service providers as being a crucial element in safety. The GOF use-based project performed operations both in Finland and Estonia and in the sea in between them. They had multiple service providers. They had many simultaneous flights operated by different operators. They even had a flight of an urban air mobility vehicle from Volocopter. And this picture shows a synthetic view. This is a photograph of somebody's laptop screen. Shows a synthetic view showing different tracks coming from different service providers being displayed together on the screen of one service provider. So GOF achieved quite some maturity in their interoperation, and they began to look at how questions like how these tracks should be labeled, and they wanted a standard labeling system for the dots on the screen. So they proposed that the label should be based on the e-registration information. So again, many requirements produced about tracking related to the implementation details, the minimum operational performance, and the interoperability that's needed. So altogether, the 19 projects covered, that means explored, didn't prove the full maturity of, but explored most of the services which are described in the chorus final CONOPS. The ones which are on the right side of the screen here, which are not covered so well, are mostly services which were only introduced in the final version of the chorus CONOPS. So these were not known by the demonstration projects as they were being set up. Things like communication infrastructure monitoring, which is producing a map of areas where there is poor communication coverage. These were services which the Chorus project produced latterly, which were not quite so critical in the initial set of U2 services which were being explored. So what are the conclusions that we can draw from this work? So all of the U1 and almost all of the U2 services have been demonstrated. These demonstrations occurred in situations with managed risk. So the ground risk was certainly minimized. We didn't take unnecessary risk. And encounters with manned aircraft was supervised. There wasn't so much unexpected stuff going on. The services related to core operations were well explored, but the services related to unusual events had less coverage. Things like emergency management, incident reporting, and accident investigation. And a number of questions remain open to be answered, particularly about how we translate into implementation, about how we get some standardization done, where we go next. But some of the basic ones, like common altitude reference, this was something that other people were working on at the time of this. So the SESAR program didn't focus on this so much, but is now being explored by the SESAR project Icarus, which is an exploratory research wave 4 project. So there's been coverage of U2. We have a reasonable state of maturity. And now I'll hand back to Robin, who will take us to Giancarlo.
Thank you very much, Andrew. Now, having heard a summary of the state of where we are with the maturity of U2, I think you'll agree there was some really excellent work that's been done to show that U2 is at a pretty decent state of maturity. We'll now hand over to Giancarlo Ferrara. Giancarlo is a former air traffic controller and a computer science engineer in the Eurocontrol Experimental Center with a wide experience in operational and the technical domain of CNS-ATM, with a special focus on R&D and safety aspects. Before moving to Eurocontrol, Giancarlo has held senior executive positions in ENAV and TechnoSky, as well as with SICTA. Giancarlo was a lead contributor to the results consolidation of the SESAR JU Space Research Program. Giancarlo.
So good morning to everyone. I hope you can hear me. I will just put on the presentation and I will start my section. Can you see the presentation?
Yes.
Okay, thank you so much. So good morning to everyone. And I will present, let's say, the work we have done on the U3 maturity, and I will start from what Andrew was saying. As we have just heard from Andrew's presentation, the first set of SESAR 2020 U-Space projects recently closed have already addressed all U1 and almost all U2 services. So along the same line, we should also recognize that a lot of work has been done for the U3 services by several SESAR exploratory research projects, and also from, let's say, from a very large-scale demonstration. But so far, as you can easily retrieve from the present U-Space services mapping, just a limited set of U3 services have been identified and defined. So the main advanced services explored so far are referring mainly to the mission and conflict management areas, as you can see, as well as to the U-Space ATC collaborative interface. So far, the U4 services have not been addressed yet, and these will be subject to some future R&D requirements that Ludo will present later in the next session. So what I'm going to present to you today with the following slides I prepared is the high-level overview of the U3 services explored so far, and also the relevant level of maturity we have achieved to the first cluster of SESAR 2020 U-Space activities. In any case, do not be scared, since with my presentation, I'm not going to bother you with too many technicalities and details, hopefully. So what we can say to set a bit the scene on U3, U-Space advanced services are expected to have the potential to support more complex operations in areas with a high traffic density, and may include capacity management functions and assistance for conflict detection. At the same time, in the near future, the increasing level of US automation, in addition to more reliable means of communication control, will also lead to a significant increase of operations in all types of scenarios. And in this framework, the development and deployment of some new U-Space advanced services, such as the U3 and U4 that we were mentioning, is expected to further enable the integration of some actors, some new actors like the urban air mobility, and will also allow more complex operations in high density and high complex areas, such as in the urban scenarios, with integrated mixed mode traffic operations. As anticipated, the work done by SESAR 2020 projects for U3 has been already very relevant, but demonstrated in scenarios with managed risk conditions to have a low level of ground risk and also controlled interactions with manned aircraft. This has been highlighted by Andrew in the conclusions as well. This implies that we should recognize so far the U3 maturity is not complete, and we should also have some additional R&D activities on U3 advanced services. Of course, some of these services will be more important and critical than others. Services such as dynamic capacity management, tactical conflict management, and collaborative interface with ATC could be considered key U3 services that could make U-Space scalable and robust enough to support the future expected operations. But not only, of course. More advanced U-Space services and capabilities, as we have seen, should be developed, mainly to enable significant increase of operations in more dense and complex scenarios, and also to allow a safe and equitable integration of the US and urban air mobility operations into the airspace, but also to develop higher level of automations and more advanced forms of interoperability with the air traffic management and also with the unmanned aviation. So finally, we should get more automated detection and avoidance capability that generally are airborne capabilities that are fully integrated with more tactical U-space management services that, of course, are more ground-based. And these should be addressed. What we can say about the coverage, as Andrew was showing for the U2 services. So far, even if a lot of work has been already done by some exploratory research projects and very large-scale demonstrations, the coverage and the maturity of the U3 services is, for some of them, still not complete, as it is shown here in the present slide. Indeed, while the dynamic capacity management service was covered by various demonstration projects, we should also recognize that only a limited number of configurations were tested, addressing the tactical conflict resolution service. Notably, some of the projects that were addressing the tactical conflict resolution service have been Vutura and Safir project, as we have seen in Andrew's presentation, which delivered a first set of valuable conclusions that are very interesting and will provide a very good added value for the future activities as well. Similarly, a number of activities were also carried out on the collaborative interface with the air traffic control by projects such as GovU Space that was mentioned by Andrew, Vutura as well, and SafeDrone that were developing and demonstrating some interesting initial solutions with reference to U3. Along the same line, we can also say that dynamic geofencing and advanced conflict detection has been tested by the Domus project as well. The results of these activities were showing that the technology that is capable of supporting this function, dynamic geofencing, is currently not sufficiently mature, could not be considered mature to meet all the advanced services requirements. But this is expected to develop quite fast in the near term to allow the required performance to enable the dynamic geofencing that is a key service for the unmanned vehicles, especially the one that are operating beyond the visual line of sight. At the same time, the GovU Space project has been also working as other projects like Safir and Vutura on the integration of manned and unmanned operations, and Andrew was already mentioning that. These manned and unmanned operations that were happening in the same airspace were defining and testing also some solutions that are relying on the collaboration and the data exchange. And this was done by linking ATM information and with U-space traffic information, so allowing operators and pilots to get a common situational awareness to improve the relevant safety levels. So this was already addressed by Andrew briefly in the presentation of his section, but as I said, a lot of work has been done on this subject as well. Another important thread referring to U3 services has also explored the so-called airborne collaborative and non-collaborative detection avoidance system. One of the projects that was addressing these capabilities has been Perceived project. But of course, to get the required level of maturity on the use of the airborne detection and avoidance capability, this should be further tested in scenarios where we will have and we will not have the ground-based tactical conflict resolution service, mainly to look at the relevant interoperability issues. What I can say at the end of this slide is that several exploratory research projects and very large-scale demonstrations such as GovU Space, Safir, and Vutura have also addressed and demonstrated how multiple U-space service provider can manage and support specific drone operations in a given airspace. But on the other hand, we have to say that the SESAR demonstration that were focusing on the interoperability of multiple use-based service providers were generally referring to simple scenarios with some specific managed risk conditions at the border that were also not allowing to achieve a high level of maturity. So further activity will be required on this subject. This implies that on the interoperability of use-based service provider, we still need to do some work, and we should focus mainly on scenarios having a higher complexity, but also a higher density of traffic that will prove that this is feasible. Oops, sorry. So to conclude, what we can say that the first set of SESAR exploratory research projects and very large-scale demonstrations have already started to address and demonstrate the feasibility of some early U3 services, but in scenarios quite simple and also under managed risk conditions that were required to have very low ground risk and also have controlled interactions with the involved manned aircraft. So no unusual and unexpected events were considered. These scenarios, of course, with the limited level of complexity, were generally referring to some specific areas like rural areas, sparsely populated areas, or even in ad hoc segregated airspace with low density of traffic. What we can say that Andrew was already addressing the point that, of course, there are some services that were addressing the management of unusual events that were not properly covered by exploratory research and demonstration projects, because this was the last part of the services that were defined by Chorus project. And we can also say that technologies that are enabling these advanced use-based services, of course, need to be further developed and assessed in all the reference scenarios to be sure that the required performances are in place. For all the above mentioned reasons, so we can say that U3 services could not be considered completely mature and will be subject to future R&D activities. And we will see later with Ludo what are the R&D needs that we have still on the table. On the other hand, making reference to the first set of U3 demonstration results, we have also to recognize that services like dynamic capacity management, tactical management, tactical conflict management, and detection and avoidance integrated solution and the collaborative interface with ATC are representing some key services on which we can build. And these, let's say, are fundamental elements that will allow us to further develop the use space in a scalable and robust way. And we will also allow more complex operations. So my last slide is it said that having said all that and making reference to the briefly mentioned SESAR 2020 project outcomes, the only point I would note at this stage is that I believe it's now time to start preparing the future, working on the definition, design, and development of more advanced use-based services that are referring not only to U3 but also to U4, that are required to address the high complexity and the high traffic density scenarios that we have in front of us, that are also, let's say, requiring the integration of the urban operations and the full interoperability with the other type of traffic like urban air mobility. But for sure, Ludovic is now going to guide you a bit more into the details on these very interesting aspects that are relevant for the future activities. Thank you so much. Give the floor back to Robin, please.
Fantastic.
Robin.
Thank you very much, Giancarlo, for a very interesting presentation. I think this might be a point just to try and reiterate, having looking at the questions as well. I hope you've seen from that particular presentation and from the previous one that we have reached a pretty good maturity with the U2 level services and a patchy maturity with U3, with some being looked at more than others and some work needing to be done. And at a general level, this is a very important point, that some of you connecting may not be fully aware that we're not trying here to show a presentation where USpace is done and dusted, SESAR can wipe its hands, job well done, USpace can now be switched on. We're not there. We're still actually in the middle of doing some work, and this will be shown in more detail now by our final presentation given by Ludovic Legros. Ludovic is a Eurocontrol staff member working at the SESAR JU since 2010 and has been at the forefront of the SESAR U-Space program since its inception in 2017. Before his work with the drone community, he was in charge of the integration of rotorcraft and general aviation to the SESAR program and responsible for industrial research projects in SESAR dealing with separation management and airborne collision avoidance. Ludovic is currently Program Manager responsible for the delivery and coordination of all SESAR U-Space projects and leads the results consolidation activity. Ludo will now talk about future activities. Over to you, Ludo.
Hello, good morning, everyone. So I will share my presentation. So don't worry, I will disable my webcam to save my bandwidth, share my presentation, and I will start. Okay, just Robin to check. Do you see my slide?
Yes, absolutely. Very good.
Okay, so perfect. So let's start then. I will indeed introduce the what next. So from now on, what I can say is that everything is about convergence and integration. So you can see here, when I speak about convergence and integration, I speak about urban environments, VLOS, BVLOS operations, ATM, ATC, manned operation, airborne capabilities, USPAIR services, and ground capabilities. Everything will go to the same direction and will be integrated. This is, since the start, this is a vision. Now, even so everything is integrated, it does not mean everything has to be managed in the same way. Interoperability is another keyword in that future world. So clearly, and I think this is a message from Robin, Andrew, and Giancarlo, the 19 projects have contributed to the development of USpace. They also highlight the need for further research and development. If you want to deploy USpace services and capabilities that are needed to enable operation in environments with high complexity and or high density of traffic. And here I include as well the mixed traffic with manned aviation. This research and innovation activities can be mainly organized in the following areas: urban air mobility, USpace and ATM, and advanced services. These needs are described in the USpace brochure, and I will now introduce some of them. Starting with the urban air mobility, and I know that there was some questions about this in the chat. What do we need to do? We need to update our understanding of the urban operations. So for sure, urban air mobility refers to this ecosystem that enables on-demand, highly automated air transport services for passengers or goods with a particular reference to the urban environments. This is one of the most demanding use cases for USpace services. It requires a review of our understanding of its specificities, the traffic, the business, the constraints, and so far and so on. This could go through a review of the European drones outlook study that Robin mentioned at the start. We need to update the predicted traffic, what will be the drone traffic and the expected business activity regarding urban air mobility. As well, a study of the social acceptance of this expected traffic would be beneficial to support the future development and implementation of UAM. As an example, the needed takeoff and landing solutions have to be defined and developed to address all weather conditions and situations, including contingencies. We need to extend the drone operations beyond VLL, because in addition to the flying taxis, UAM covers all types of urban air operations that will require the extension of USpace services beyond the VLL limit. Drone operators and UAM operations will require access to higher altitudes and areas close to commercial manned aviations, such as the airports, when at the same time, flying manned aircraft in or adjacent to VLL can make use of USpace services. A safe and equitable integration of these operations with manned aviations require additional U3 and U4 services. The next bullet is about the need to develop a CDM, a collaborative decision-making to support urban air mobility. The development of interoperability and a collaborative decision-making process between the urban operations, ATM, and the city authorities is key for future urban operations. It will be therefore necessary to consider the roles and responsibilities of the national and local stakeholders, including use-based service providers, drone operators, urban air mobility operators, and ATM units that are involved. It will also be imperative to study the workflows they collectively engage in. We need to define solutions to ensure the effective interoperability of use-based service providers and the proper interface with ATM. We need to define solutions that are focused on urban scenarios, solutions that address governance and regulatory challenges, security and non-aviation aspects, and solutions that will ease the social acceptance. Finally, in my summary here for urban air mobility, we need to develop a suitable risk assessment and airspace design. Further guidance is required on how urban ground and air risk should be addressed. The same for the design of the airspace over these densely populated environments. It is still unclear how these proposed data and information services managed by ATM and use-based service providers can be integrated and implemented in this busy urban airspace. To adequately manage the relevant risk, properly design the relevant airspace, efficiently and safely manage high volumes of traffic. The primary safety hazards posed by urban air mobility traffic are collisions between a drone and another airspace users, as well as the impact on infrastructure, objects, and people on the ground. The risk associated with these safety hazards must be addressed through the appropriate certification of drones for operation over an urban environment. This has to be coupled with a comprehensive airspace architecture and appropriate traffic management system. Methodologies such as SORA are useful for assessing risk for a single or a low number of drones operating in a relatively uncomplicated real-world environment. However, this methodology may not be sufficient in scenarios where high volumes of drone traffic are projected to operate over densely populated environments. The next group of needs is about use-based and ATM. In that area, we need a robust and timely exchange of use-based information services. An efficient use-based ATM interface is required to enable an adequate, robust, and timely exchange of use-based information between the various use-based stakeholders, such as drones, operators, use-based service providers, ATM service providers, data service providers, and the authorities. The relevant solutions are expected to have a positive impact on access and equity and have to enable seamless ATM use-based operations. We need common fundamentals. As I said, information exchange will be critical to enable a safe convergence of use-based and ATM. The possibility of a fully integrated airspace without segregation between use-based and ATM users is the ultimate goal. A fully integrated ATM use-based ecosystem without segregation between use-based and ATM operations also requires the setting up of common fundamentals. Some of these fundamental enablers refer to the definition of a common attitude reference system, separation minima, safe operating distances from buildings, and fundamental aviation tenets such as airspace classification. About the rules of the air, the need to revise the rules of the air becomes necessary to consider the specificity of VLOS and BVLOS operations, of unmanned traffic in general, as well as of the mixed traffic, unmanned and manned. Such a work will go through a mapping from VLOS and BVLOS to flight rules. If that mapping produces new flight rules, then the airspace classes need to be updated. X, Y, and Z volumes that have been developed by Chorus need to be mapped to airspace classes, or guidance has to be developed on what mappings are reasonable. Finally, and not the least, automation, autonomy, and role of the human. Further work will be required on enablers for automations and autonomy for use space. This is a critical aspect. This is a critical aspect of the integration. The critical aspect will be the integration of the role of the humans, particularly when we look at the high level of automation that will be delivered by use-based services and the non-automation disparity between ATM and use-based. Between us, this is not only limited to use-based and ATM, because when we look at use-based, there will be human pilots that will coexist with autonomous vehicles. This role of the human is to be considered at this level as well. So UAM integration in the ATM/USpace ecosystem is also a specific research topic, as well as the challenge of how to support the transition from piloted vehicles to autonomous operations. Of course, the evolution of the ATM USpace convergence will need to be synchronized and coordinated with the development of the urban air mobility services and the certification of the UAM vehicles. Special consideration should be given to the operational limitations of these new vehicles and how USpace and ATM can contribute to their operational safety by protecting their operations in contingency and non-nominal situations. Advanced services. As mentioned by Giancarlo, the high complexity and high density of traffic when we speak about U3, U4 require advanced services. I cannot speak about all these advanced services. I will just pick two main examples, which are strategic and tactical conflict resolution and detect and avoid. So let's start with strategic and tactical conflict resolution. So clearly, we want to maintain an adequate separation among drones and the rest of the world. Conflict management requires shared intent, shared awareness, strategic deconfliction, tracking and monitoring, digital technologies, operational rules and procedures. Advanced conflict detection is essential for multiple drones to operate at the same time in the same airspace. USpace systems must be implemented in a common way to be able to efficiently exchange data. And all these systems have to be able to use this exchange data. Low quality, delay of input data from the other service degrades the strategic conflict resolution. These conclusions are about strategic conflict resolutions, but many parallels can be drawn with the tactical conflict resolution service. Several areas will require further investigation in order to develop solutions for strategic and tactical conflict management in this U3, U4-like airspace. Some examples. What is the impact of the fairness principle on the decision-making process? How common altitude reference and vertical separation should be implemented? How conflict should be resolved with manned aviation? And what about the interaction between the tactical conflict resolution service and onboard detect and avoid systems? And here I go to the detect and avoid. Speaking about this, I have to highlight that some projects like Perseverance in SESAR, they have already explored systems that are quite advanced and revolutionary and bring a lot of revolution, let's say. And clearly, this is a good step forward. At the same time, it is expected that in U3, in this U3, U4-like airspace, drones flying in areas where high density or mixed traffic, these drones may be required to be equipped with detect and avoid technologies. It means that in terms of R&D, Europe should address the following needs. We need to develop onboard detect and avoid capability. We need to go through a full demonstration of detect and avoid in this dense airspace with a focus on detecting equipment for cooperative intruders. Technical feasibility for detecting non-cooperative intruders and the integration with the current collision avoidance algorithms have to be worked as well. And a last example, this is the operational procedure for pilots reacting to electronic conspicicy and detect and avoid. That's for these two examples. You can see here that I'm listing as well the multiple service providers. This is not a service as such, but since the start, this is a critical aspect for the USpace concept. And I think it deserves some words. So remember, this is a key point in the vision of USpace from the blueprint. Multiple service providers operating in the same airspace at the same time. I said by Andrew and Giancarlo, the SESAR projects have embedded this principle in their architecture, in their systems, in their scenarios, and they have demonstrated this is feasible in a U1, U2-like environment. So to come back on this, in short, the challenge is simple or complex. When you have USpace services such as mission management or conflict management, when these services are centralized, this can work relatively well, as there is only one decision made by the ecosystem. The complexity comes when multiple service providers have to exchange information and have to make coordinated decisions. We need to develop specific use cases and safety critical services that support this federated approach. We need to develop solutions that define the exchange of data between multiple service providers. Some examples are failure management, discovery mechanisms, tracking when multiple sources are involved, how these services will work in this federated view. Equity and fairness principles are essential, and at the same time, they affect the service provision. Further R&D will be critical for the development of the multiple service provider concept. Some examples: how authorization will be provided in a multi-layer environment, how conflicts should be resolved in a federated systems and with a high level of traffic, the reliability of communication in this federated view, roles and responsibility for the provision of services when several use space service providers share the same portion of airspace. And another example could be the requirements for technical implementation of a fully federated use space service architecture for unsegregated airspace. In addition to these examples, there are R&D needs related to other topics, such as the telecommunication infrastructure, or services such as geofencing. I cannot detail everything here, and I invite you to read the brochure for more information. So, this is the picture as it is today. The red piece is about the 19 projects that are now closed and consolidated. You will find all the details in the use space brochure and the various reports produced by these projects. And here, this is especially for me, the opportunity to say a big thank you to all the project managers and experts who have been working with us. The blue pieces, they show that the SGU has already started to work on the future. The first one, the ER4, this is to show that we have already kicked off new exploratory research projects. They are working currently on topics such as common altitude reference, DCB, separation management, CNS technologies, and so forth and so on. We have awarded as well, this is a VLD2 piece, new demonstration projects. They will be dedicated, they will be focused on use space and urban air mobility. We have awarded our first industrial research projects that will work especially on the interface between use space and the ATC. So for sure, additional R&D will complete this puzzle in the future. In or outside SESAR, we continue to develop use space, and I'm sure the use space brochure and the outcomes of the 19 projects will fit this work. I already saw in the chat a lot of references to initiatives that are already ongoing outside SESAR. I'm very happy to make this presentation and to deliver this brochure today. Thank you.
Thank you very much, Ludo, for that very clear picture of where we are and where we have to go. So that completes absolutely exactly on schedule our presentations for today. So my first thing I must do is to thank our presenters for clear and timely presentations that tell the story of use space research so far. Allow me just to summarize, because I've been looking at some of the questions as well, is that we have completed what amounts to a first stage, a first 3-year program of use space research in Europe. We've come up with a roadmap. We've then started to research alongside the roadmap with a wide variety of stakeholders. And what we've achieved is to be able to show that the levels of services is maturing. The labels that we've attached to these levels of service has so far proved to be useful. So now we can build as we develop a capability, and that we've got to U2, and we're pretty confident that most of the U2 services that we've envisaged have been well studied and well covered. That doesn't mean they're ready for deployment. It means now that we've got to a level of research maturity that there's some solid material that can be built on. Now, what does that mean? That means standardization, that means regulation, that means that other stakeholders and developers and operators need to be able to build on this material. And of course, service providers have to be there to be able to deliver the services using information that is appropriately qualified, that we know the data quality is reliable, and there's many, many unanswered questions that are more towards the deployment side. So what our research has done is we've looked at a number of things, and we've said, okay, here is a sweetie shop of things that we think that people can pick and develop on. And to the level of U2, we've got a pretty high degree of confidence that we've done some good work that is useful to implementers. At U3, well, these are more advanced, and really there is the biggest jump, if you like, in our roadmap is between U2 and U3. In U3, there's a much higher level of automation. There is a lot more expected from the vehicles themselves. There's an expectation that there's more collaboration between the different service providers with air traffic management, that we know more how manned aircraft can fit into this complex picture. And so we're still quite a few steps away, as Ludo was just pointing to, before we can really have confidence that we know what U3 is going to look like. So right now we're in a pre-planning, trying strategically to sort things out environment, which is where SORA plays its part. In the future, we're looking to a much more dynamic environment, which will allow the increase in service provision, increase in drone operations in a much more dynamic fashion, but we're not there yet. So I hope that summarizes essentially where we are now. Just so that you know, we already have a number of projects. I can't remember off the top of my head, but it's something like 8 U-Space projects that are starting off right now within the SESAR environment. But as one of the question posers on the on this WebEx has pointed out, that SESAR is not the whole story. There are a number of other stakeholders who are involved with this, and we have to acknowledge that and work alongside those as much as we possibly can through open forums and workshops and so on. But also, we'd have, which some of you may be members of and others may not know about, the European Network of U-Space Demonstrators. Now, this is an organization that is co-chaired by the European Commission, EASA, Eurocontrol, and the SESAR joint undertaking. The idea is to try and bring together as many stakeholders who are closer to deployment or who are trying to deploy things now, to share lessons and learn communally from the activities in U-Space that include SESAR but is far from being uniquely SESAR. If you don't know about this, I suggest that you do check it out on the Eurocontrol website. And indeed, if you look quickly, you'll find out that actually we're in the middle of a series of 3 webinars on U-Space from the network of demonstrators right now, with the next one happening on the 19th of November next week, and then one the following week as well. So there's still time to register for those. And that if you need to see a wider picture of information that is closer to deployment, I suggest you check that out and see the story continues. So another question that's been raised a couple of times is, how are we taking the U-Space program beyond Europe, and how are we ensuring there is consolidation with the international program? It's an excellent question. We have to start somewhere, and we've started with Europe. We've started with European needs. There are very specific needs within Europe that are not in the same, not the same as some other major stakeholders, like, for example, the United States. But nevertheless, we need to coordinate with these people, and we have a number of vehicles to enable us to do that. We have a memorandum of cooperation with the FAA that includes a specific research exchange between what's going on in the US and here to try and increase harmonization. But of course, there's also the ICAO UAS advisory group. Now, this is quite an important forum, and there are members from Europe. I'm personally a member as well as other members from Eurocontrol and from other agencies within Europe. We participate regularly in this truly global forum. There are people from all the corners of the globe looking to try and coordinate what in ICAO parlance UTM will look like, and is producing some documentation, including a UTM framework document complete with advisory annexes that people can refer to. Version 3 of the UAS framework document has just been published by the advisory group and is available on the ICAO website. So there is external coordination going ahead. We fully realize that the need for global harmonization is there, but when we're doing our own research program, we are looking at Europe, and we're using European stakeholders to provide an answer for Europe whilst coordinating. I think that's our approach. So that's it from me for my summary for now. I'll just hand over to my presenters for a moment to see, do they have any issues they wish to raise on the general summary before we go into specific questions? Can I start with you, Andrew?
No, that's a good summary. There's some interesting questions coming. That's why. Hurry up.
Very good. Thank you. Giancarlo?
Yeah, the same for me. It's you were doing a very good summary. So, but there are some questions already on the question box.
Very good. And Ludo?
Yeah, indeed, a good summary. And looking at the questions and the recs on the chat, I mean, this is exactly what we mean and where we are since the start, to have all these people coming with a lot of ideas, with a lot of questions, with a lot of will to move forward. It's true that we did and we will continue to do our best in SESAR to contribute to the development of USpace. At the end of the day, we are not alone, and hopefully we are not alone to develop such solutions, such a concepts, and because it really deserves to work all together in Europe and outside Europe as well, as I saw a lot of questions about this. Nothing
Very
to
good.
add.
Thank you very much. Now, I'd like to start with a rather difficult one. We did have a question that steps towards the regulatory issues, which I don't want to talk about. We should start off by saying this is a technical research program. We're not really at the moment here to talk about the regulation, but nevertheless, there was a question that how do we view the difference between, or the perceived difference maybe, between how we view USpace as a set of services and the quote from the question, EASA's concept of USpace as an airspace. I think this is an important question that we can't really step around, unfortunately. So would any of the speakers like to say anything on this one, or would you like me to start?
Could I jump in?
Yes.
So the term I've heard used in EASA is USpace airspace, which is a rather confusing collection of words, but it means airspace in which USpace is offered. So I don't think they really see it as an airspace, but they see it as a set of services which is available in some airspaces. Does that tie in with your view, Robin?
Absolutely, I think it's vital. The term that's missing here is geographical zones, and the geographical zones are to be identified, and then USpace services will be deployed within them. So USpace itself is not viewed as an airspace. It is an airspace within which services can be deployed. Exactly which services depends on the geographical zone. So yes, thank you. Let me think the question.
Robin.
Yes.
Maybe just to add something on top of this, and yes, I fully agree with the answer from Andrew and what you said, Robin. Just maybe to highlight the fact that, and I would like to come back on the slide that you have been using, Robin, in the introduction, explaining how we had to set this complex program in this short timeline. This is what we did in terms of R&D, and I have to say that this is what the EASA did in terms of regulation. To manage, they had to manage the call to have a regulation, to have this text available in a very short timeline in a complex environment. And I think, as we did for the R&D, they did their best to provide an answer to the questions by using the existing framework. That's what I would like to add.
Very good. Thank you very much indeed. Okay. I'm just trying to look through the questions. Presenters, when you were looking through the questions, was there anyone that you particularly wanted to answer in open forum? Because there have been a number of different questions, which is I'm trying to look through now. Many of them have been answered actually on screen. So I think we need to there's been some questions about microservices and micro weather, and are we looking at these? I think this is an important issue. If we are saying that microservices or the whole of USpace is actually a service-based architecture, the provision of such services is rather important. Andrew or Giancarlo, do you wish to say anything about the microservices?
If you like, I can jump in saying that, okay, some work has been done as for the U3, but still there is a lot of work to do, especially when we approach the urban airspace, as you know, because some conditions, local conditions could be very sensitive and could affect a lot the urban air mobility, for example, type of operations, as well as the drone operations. So I think, let's say, the dossier is still open there. There is a lot of work to do, even if some activities were done from some projects like Terra and others, I guess. So, but still, we are, let's say, we are having an open door for future activities on that.
Very good, thank you. Any other comments? So I think the next question is one that I'd like to raise, and it's quite important. It's about separation. As we've talked about here, we've said that most of the work that we're doing is to do with planning and with strategic separation, and we're only just beginning to look at any form of tactical separation, let alone tactical separation from manned aircraft, which is a real issue that will need resolution in due course. There was a question about separation standards. I'm wondering, Andrew, may I ask you to start to talk about how we see the evolution of from a strategic to a tactical separation, at least philosophically, because I know the research is still in progress. Would you like to kick off on that one?
So the view in the design of U-Space is that the first approach will be pre-flight or strategic separation. So we will have some airspaces in which the only separation provision will be this pre-flight separation. And the aim will be to understand how confident we are about the positions of the aircraft and separate them in regard to that confidence. So if we only have the plan and there's a lot of uncertainty in the plan, then there needs to be a large separation between that aircraft and another. If the plan is guaranteed to be followed quite precisely, then I think that will be the kind of constraint that we will see in some airspaces. There will be a maximum tolerance on the plan, then we can set the separation in accordance to that level of confidence. So we imagine a progressive range of separation being given depending on the demand from the traffic and the resulting technical requirement on the aircraft flying. Tactical separation is separation instructions given during flight. And in the U-Space ConOps, we talked about two flavors. There's tactical separation under the control of current air traffic control, and that will be as now, and tactical separation under the control of U-Space. And there is a question there which is still unresolved, which is whether these U-Space instructions will be mandatory or advisory. And the separation that we can achieve will depend on which of those two is decided. But clearly, in order to have a mandatory U-Space separation service, there needs to be significant confidence in the systems providing these separation instructions and significant insurance for the liability of those providing these instructions. So certainly in the USA, the direction is to give advice to the pilot and leave all of the responsibility with the pilot. So U-Space in that view would be an advisory service. So we would have probably quite, let's say, generous separation in a U-Space controlled in that manner.
Thank you, Andrew. Giancarlo, are you raising your hand or stretching? Okay. Ludo, do you wish to add something?
Not on this specific point, maybe just to highlight, because I see there are questions about this separation, question about dynamic capacity management. So as I said, we have already started some projects. I do not say that this is the only project in the world, but in SESAR, there are already some projects about separation management, dynamic capacity management, and CNS technologies, separation minima. So there are already some projects that you can go to the SESAR website and see the references. Here I'm thinking about Icarus, Dacus, and others. So that are bubbles as another examples. So we have already such project that will dig into the details of these very specific aspects. And as Andrew said, there are a lot of questions. Liability is one of them. I saw questions about use of GNSS and so far. So there are all these technical questions that have to be dig into the details to provide, let's say, a formal answer to these points.
Thank you, Ludovic. I'd just like to add something here, which is a layer that hasn't really been touched on, but has been mentioned in some of the questions. And that is what you might call situational awareness between aircraft, between drones, between manned aircraft and with air traffic control. And clearly, choice of technology here is really very important. And there are many questions to do with cost, with interoperability. Clearly, ICAO's view on the fitting of 1090 ADS-B to drones, or rather not. And then the possibility of using technologies from other sources, such as FLARM, or indeed new technologies. And I'd just like to kick off this discussion before we go to the panel with a little, just to mention that this is something we have already looked at in the SESAR program. Just as an example, that the Perseverite project did look at the equipage of aircraft to avoid both obstacles and other drones. And checking out the material will be a very, very useful exercise for you, because it's quite an interesting conclusions they came to. But the one I wanted to raise with you particularly was a very innovative idea that allowed drones to be aware of each other and make calculations to avoid each other simply by using Wi-Fi. Now, there are certainly issues about whether this could work properly or not, and the range was fairly limited, maybe 800 meters. But nevertheless, the true innovative feature of this was not requiring the vehicles to actually connect to each other using Wi-Fi, but using the broadcast features such as the SSID. Now, if you pick up your mobile phone now, wherever you're sitting, you'll look at the list of Wi-Fi's available, and you'll recognize those around your house. You'll also see lots of others from your neighbors, from shops, from people walking by. And this is because the mobile phones or your iPads broadcast the SSID information. And this is available almost instantly. So what the innovative action taken within the Perseverite project was to encode the drone's position into the SSID broadcast. Now, this meant that any other vehicle that simply had a Wi-Fi, which of course means almost every drone there is, can receive this signal, and without having to connect to a network, can read the information on the position of another drone. It can then perform onboard calculations to know whether it has to avoid. And they've got films on their site demonstrating both a collision they tried to make happen but couldn't, and then walking around carrying a drone, a flying drone, and watching it move out the way. Yes, there's a whole bunch of work needs to be done about, could it be standardized? Could it be certified? Is it of any value to manned aviation? But I think it's a very innovative solution that comes directly out of the SESAR program that has the potential, anyway, to answer one of the biggest questions that we have at the moment, which is vehicle-to-vehicle communications at a very low cost using technology that already exists. So before I'd like now to throw to the floor, any thoughts on vehicle-to-vehicle and situational awareness between drones, manned aircraft, and ATC?
I would welcome that this Perseverite work is taken further. It was a very interesting project which produced some open source deployments which you can take and use today. I am just slightly frustrated that we in this program don't have a means to take it further. So this is an appeal to the audience to go and look at their work and see if you can capitalize on it, because we're unable, but it does show a great deal of promise, as Robin said.
Okay, we have 7 minutes left. Ludo, please. Yeah, just to complete what Andrew said, it's true that Perseverite is a good example. This vehicle-to-vehicle, whatever the vehicle, I would say, is a critical aspect since the start. And personally speaking, when we were at the time of the U-Space brochure, U-Space blueprint, I remember that this was a topic which was not really touched, or at least the only sources of information that I had were coming from the automotive area, I would say. When today, looking at the work done by Perseverite or even Eurodrone in their demonstration, we have very good examples of solutions that work in let's say in the ATM, in the manned aviation, in the aviation world. And when I say that work, they all went to the real world. I mean, they persevered again for this example. They have won some challenges, so they had to demonstrate, thanks to flight trials, that it works. And that's something which is important, which is important. Even if I recognize what Andrew said, that it's at program level, it's always difficult to show all the details and to highlight all the details. And this is why we have, for the first time, this brochure. It's really to invite you to go to the projects. You will see in the brochure, you have a presentation of each project with the consortium, with the people who have been working on them. Then you can go to them, you can go to their reports and access to their information, because even if I am very proud of the brochure, the details are there. And you have to go there to meet the project people and to check and to use their material. And this is really, for me, the aim of this brochure, to invite you to access to their outcomes.
Yeah, and from my side as well, I'm fully supporting what you said, Robin and Andrew and Ludo. It's really important, because these quick and dirty solutions also in the short term, that could be also very good for the future implementation, will give the boost. So I would invite as well all the participants to, as you said, to capitalize a bit on the results already achieved and perceived was a very good example, and to see how we can push forward towards implementation. This is up to the stakeholders as well, as you know.
Thank you all. I think we have 4 minutes to go, or 5 minutes to go. I just want to say a couple of admin things before we maybe look at some final questions, just as the time comes to a close. As you may have seen from the questions, the presentations will be made available via the SESAR website, as will a recording of this session. And as Ludo very importantly said, please do go and check the project material. We can only give you a flavor of the overall program view here, but there is a wealth of detail in the individual project reports that are publicly available. And almost all of the projects, 19 projects, have also produced formal peer-reviewed academic papers, which have also been uploaded. And so there's a lot of open information there that you can look at very great details. I recognize that there are a number of questions that we haven't had time to answer individually. I'm sorry for that, but with a presentation of this size, I think that's inevitable. But worry not. What we will do is we will go to the list of questions and we will try to find a way of responding to all the questions and then publicizing the list of answers once again on our website, so that if you did ask a question that wasn't answered, then hopefully you'll find the answer there. There have been a number of questions about individual implementation issues and regulatory support for it and this kind of thing. Just bear in mind that we're a SESAR technical research program. We do recognize that the regulatory and standardization activities are of vital importance, but what we do is provide material that can support that activity, not actually conduct that activity. There are other agencies far more competent to do that than we are, but hopefully what we provide for them will enable them to do that, that kind of activity. So as we draw to a close in the final 3 minutes, what I would like to do is to go one by one through my presenters, just to escape from any closing remarks, starting with you two. So Andrew, would you have any closing remarks, please?
Just before that, Robin, it's Remy. Just before that, Robin, there is also a poll that we just launched with a few questions concerning this webinar. So if you can all reply to this polls, it's next to the questions tab. Sorry for interrupting this webinar.
No problem. So thank you for that, Remy. So please, if you wish to, there's a poll beside the questions tab. Click on the polls word, and then it won't take you more than a few seconds to answer the questions. And then we'd have an idea of how well we're doing. Thank you. So Andrew.
No real big remarks to make. I must thank everybody who joined today, and I would really encourage you to download the brochure and read it. And then if that proves of interest, jump into the reports themselves, because there's been a huge amount of work done, and we are just presenting the tip of the iceberg. But there's many interesting conclusions to read, and we couldn't possibly get into them all in just 1 hour.
Thank you, Andrew. Giancarlo.
Yeah, just to remark what Andrew was saying, it's a good, the good suggestion that I can provide is to have a look to the report and also have a look to the to have access to the reports provided by the project, because from there we can start to build, let's say, the next R&D activities, what will push forward, you know, the required developments we need for having the U-Space really deployed at the end of the day. So, and I would like to thank you, all the participants as well, for, let's say, posing a lot of questions that we were trying to answer at a high level, and we will address later as well. There are very good questions that we should address, and we'll be back to you. Thank you so much.
Thank you, Giancarlo. And finally, before I hand over to Ludo, I'd just like to say personally, Ludo, thank you very much indeed for leading and guiding this complex project throughout the entire gestation. I think today is a great moment for you and for Europe, having a document like this. So without your personal effort, this would not have been possible. So thank you from me. Any final thoughts?
Yes, thank you, Robin. Indeed, for me, especially speaking, this is a special day today because, as I said yesterday evening on my LinkedIn account, the job is done. We had this mission during these 3 years to develop, to contribute to the U-Space development. It was not always easy, or it was always difficult, I would say. But the positive aspects, that to have all these experts, all these people with this goodwill, this expertise to make it, I think it was a very funny job at the end of the day. Now it's clear, as Andrew said, this is the top of the iceberg. Please go to the brochure. Florian said it at the start of the meeting. This is the first time that we have such kind of document in Europe and maybe in the world. So have a look to it, but please go to the technical report. This is where you will have the details. And let's continue this work together because U-Space has still to be developed. Thank you so much.
Thank you very much, Ludo. And finally, remains from me, thank you all very much for participating. Your presence has been very, very much appreciated, and I hope you've learned something. Let's keep up the communication, and all the best to everybody at these difficult times. Thank you all, and goodbye.
Bye-bye.